Very good morning, students. So, welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8. Our ongoing chapter, that is chapter number 2, motion in straight line. And today we are entering into the session number 3. So far we completed 2 sessions, 2 classes on the topic of motion in straight line. Now today we are entering into the 3rd session. So before going for the today's session, if you just recall what we learned so far in the chapter motion in straight line. So just to have an introduction about the what is motion or what is rest, we defined them with some examples. Of course, I recall the types of motions which you already learned in the 6th and 7th classes. We recalled. Then we have seen the terminology, the terms related to motion. When a body is in motion, what kind of physical quantities will come across? In that discussions, we discussed about distance and displacement, right? Speed and velocity. These 2 topics we covered in the last session, right? Then we'll discuss today about the what is acceleration and retardation, right? Acceleration followed by equations of motion, means the relationship among all these quantities. So motion and rest we already read. Motion is nothing but the body changes its position with respect to time or with respect to surroundings, then body is said to be in motion. If it is not moving, if it is not changing its position, it is said to be at rest. So in our day-to-day life, from morning to evening, we'll see so many types of motions like translatory motion, linear motion, curved motion, circular motion, oscillatory motion, rotatory motion, vibratory motion, random motion, and so on, many types. Okay, all these we've seen with examples. So when once body started into motion, every moving body will have distance or displacement, speed and velocity. Of course, now acceleration, retardation also. So after knowing about acceleration, retardation, you should know what is the relationship among all these. So there are some equations which shows the relationship between distance, displacement, velocity, speed, acceleration, retardation, and time. That relation is given by equations of motion. So today we are going to discuss about acceleration, retardation, and equations of motion, right? Shall we? Okay. So as we move to the today's topic, right here, we are at the page number 19. Page number 19 of our material, where we are starting about the acceleration. It's a common word, right? Suppose when your father starts taking you to school by 2-wheeler or 4-wheeler, when before starting of the vehicle velocity is 0, right? That is called initial velocity. Starting velocity is called initial. Say we can show it by u. If u is the initial velocity, right? U is the initial velocity. Then he started raising. You know, accelerator. Accelerator is used to either increase the speed or decrease the speed. Correct? So after some time, the velocity increased because you had reached the school. So the time you reach the school, what is the final velocity you ought to say? That is called final velocity. To move from U to V, it takes some time. Suppose T is the time. Right? See, when you have started moving from home, either by cycle or by two-wheeler or by four-wheeler, initially the velocity is zero only because your cycle or vehicles are at rest. When you start accelerating either by legs or by hands, the final velocity reaches to V. So to change from U to V, it takes some time, maybe 5 minutes or 10 minutes to reach your school. That is T. According to the definition of acceleration, acceleration is nothing but rate of change of velocity. Rate means time. At how fast it takes place. That is change in velocity. Change in velocity is nothing but final velocity minus initial velocity by time. That is A is equal to V minus U by T. Right. So acceleration is given by the formula A is equal to V minus T. So common, generally we can say acceleration is nothing but increasing the speed. Speed up. Speed up is accelerate your work. Speed up will call that is. Okay, that is mathematically given by final velocity minus initial velocity by time taken. That is V minus U by T. Right? So as we are using the velocity word, it is a scalar vector quantity, and units of are meter per second square in SI system, centimeter per second square in CGS, because velocity units are meter per second. And again, time units are second. Meter per second by second is nothing but meter by second square. Right? Clear? So, the resolution of a particle and the time rate of change of its velocity, it may also be defined as change in velocity per unit time. To describe how velocity of object changes during a given interval of time, now introduce a new idea of acceleration. Right? Change in velocity by time. Clear? A is equal to V minus U by T is the mathematical formula for acceleration. If you know velocities, you can calculate the acceleration. For example, see, suppose U is equal to 0 because you are starting from home, from rest only. So V is equal to 10 meter per second. To come from 0 to 10, it takes time of 2 seconds. Example. Then what is acceleration? A is equal to 10 minus 0 by 2. That is 5 meter per second square is the acceleration. Simple. A body starts from rest, or a cycle starts from rest. A vehicle starts from rest. Rest means initial velocity 0. Right? As initial velocity 0, we can take the acceleration as 5 meter per second square. 5 meter per second square, right? Clear. So this is a very important term when a body is in motion, that is acceleration. It is a commonly used word also in our day-to-day life. You all know that what is the accelerator, role of the accelerator, either to increase the speed or to decrease the speed. So when you come to the part of decreasing the speed, it is called as deceleration or retardation. Okay. Something you can see here. Misconception alert for deceleration and negative acceleration. Deceleration is always refers to acceleration in the direction of opposite to the direction of velocity. Right? So deceleration always reduces the speed. Suppose you are started with a great speed of 10 meter per second. Your vehicle started. After some time it becomes 0 because it stopped. When you apply the brake, it stopped. Your destination came in time second of 2 seconds. Okay, then same formula. A is equal to V minus U by T. But here V is 0. 0 minus 10 by 2. That is minus 5. So what is minus 5 minus indicating? That is deceleration or negative acceleration. Means negative indicates that the body is stopped or its velocity is decreased. If the velocity increases, you can get a positive value. If the velocity decreases, you get the negative value. That is called the deceleration or retardation or negative acceleration. Okay. Clear? So there are so many examples are given for that. For negative acceleration and deceleration, different cases. We can see the different type of answers. So of course, there are acceleration to be either uniform or non-uniform. If you increase the velocity time to time, that is, for example, first 5 meters, you increase the 5 meters per second. Next 5 meters, 5 meters per second. Like that, we are increasing constantly. Then it's called uniform. For example, simple way there. Here to here you are going, right? A, B. Suppose two destination. It is 100 kilometers, 100 meters, it is 100 meters, right? So acceleration here is 5 meters per second square. Here acceleration is 2 meters per second square. So you covered this distance with some time. You covered this distance more time because acceleration is less. So suppose it's also 5 meters per second square. First 100 meters you covered with the acceleration of 5 meters per second square. Second 100 meters also it's same. Then what we can say? The body is accelerating uniformly. Correct? If increases the velocity, the rate of change of velocity is same throughout the journey, then the body is said to be moving in uniform acceleration. If not, suppose first 100 meters 5 meters per second, second 100 meter 2 meters per second square. So acceleration is reduced. Means body is moving slowly. So it is called non-uniform acceleration. Okay. A body is said to have uniform acceleration if magnitude and direction of the acceleration remains constant. So again it changes. When the magnitude and direction change, magnitude means speed, changes from time to time. First it is 5 meters per second, great acceleration, but later become only 2 meters per second square. So definitely second 100 meters take more time compared to first one because acceleration is reduced. Similarly, instantaneous. Anytime, what is the acceleration of your vehicle at any time is called instantaneous acceleration. Already we discussed for speed, velocity also have the same types. Right? So this is completely about acceleration and retardation. Acceleration is nothing but increasing of velocity with time to time. Whereas deceleration is nothing but decreasing of velocity. Right? Clear? So before going for the next topic, we'll see the video on acceleration and then we'll move to the next part of the chapter.
Acceleration and deceleration. Objective: to learn the concepts of velocity, acceleration and deceleration. In another session, we look at the concept of speed. In this session, we will learn about the concepts associated to speed, velocity, acceleration, and deceleration. Speed is an indication of how fast an object is moving. When a moving car is covering a distance of 5 miles in 30 minutes, we would say the car is moving at a speed of 10 miles per hour. Velocity is the rate at which an object changes its position in a specific direction. It is a vector quantity, which refers to the direction the object has moved and measures distance of movement. Let's think of a car moving at a speed of 10 miles an hour. If we specified the direction our car was traveling in, north, for example, we would say the velocity is 10 miles per hour north. Simply put, speed in a direction is velocity. Next, we have acceleration, which is the rate at which an object changes its velocity over a period of time. Let's go back to our car. This time, the car begins heading north at a velocity of 10 miles an hour, increases its speed halfway through the trip, and ends at a velocity of 20 miles an hour. Here, the velocity has changed, and we would say that car has accelerated forwards. The average acceleration of an object can be calculated using the equation average acceleration is equal to difference between the velocities
Change in velocity.
Vf minus Vi divided by
The final
time,
velocity.
where
Initial
Vf is the final velocity and Vi is the initial velocity.
I took U.
In our example, the initial velocity is 10 miles per hour and the final velocity is 20 miles per hour.
20 by the 10.
Substituting the values in the equation, we get 20 minus 10 divided by 1 hour. That comes to 10 miles per hour square. But we express acceleration as velocity per time units. So, it will be 10 miles per hour per hour. These units can be mathematically simplified to 10 miles per hour square. The opposite of acceleration is deceleration or negative acceleration, which means we are decreasing the velocity. If the car begins its trip at a velocity of 10 miles an hour and ends at a velocity of 5 miles per hour, we would say the car has decelerated.
Decreasing of speed.
Summary.
P.
Speed indicates how fast an object is moving. Velocity is the rate at which an object changes its position in a specific direction. Acceleration is the rate at which an object changes its velocity in one direction over a period of time.
Right.
Deceleration is the rate at which an object decreases its velocity.
So you can note down these points.
Only 29 rupees, 6 days Vedic Maths Summer Camp. Don't calculate in
Okay, anyway. So it is totally clear what is the acceleration, what is the deceleration or retardation, or it is also called as negative acceleration. Right? So we are very much clear about all the terms related to motion. When a body is in motion, it will come across distance and displacement, speed, velocity, acceleration, retardation, and time also. Time plays very important. You see what terms what we come across. Right? We know what is U, V, A, S, T. These are the 5 terms, 5 physical quantities or 5 terms will come across bodies in motion. So U is the initial velocity, V is the final velocity, A is the acceleration or retardation, S is the distance or displacement, T is the time. Okay. So all these terms, they are not independent. If you know one quantity, you can find out another quantity. Means there is a relationship is there. The relationships among all the terminology related to motions are called equations of motion. Means we can find equations using these all quantities by to show the relation between them. For example, see. So there are 4 equations of motions are there. First one is V is equal to U plus AT. You can note on this in notebook. Later I'll show the equations of motion. I'll tell you how to derive the derivation also, right? So equations of motion is nothing but relation between all these things. So second one is S is equal to UT plus 1 by 2 AT square. Right. So third one is V square minus U square is equal to 2AS. And fourth one is Sn is equal to U plus A into N minus 1 by 2. So these are all 4 equations which are called as equations of motion. So by using these equations, either you can calculate final velocity or initial velocity or acceleration or time. As per given data, you have to select which formula is suitable to find out the one unknown quantity. When 2 unknown quantities are known quantities are given, unknown you can find out by substituting in the formulas. So first one is V is equal to U plus AT. Not only notebook first. all of you. I'll show you the definition also, derivation. Okay. So V is equal to U plus AT. Already we discussed, we came across in last 7th class also. S is equal to UT plus 1 by 2 AT square or half AT square. V square minus U square is equal to 2AS. Last one is Sn is equal to U plus A into N minus 1 by 2. Or you can write Un also. Right, correct? Un, N base. N is a particular time, particular second that we discuss. So, these are all called equations of motion. They are clearly explained here. These are the various relations between V, U, A, T and F. For moving the particle, notations are used. What is V, what is everything is given. Right? Sn also given. Distance traveled in the nth second. So, distance traveled, acceleration, final velocity, initial velocity. When particle moves with zero acceleration means there is no change in velocity, moving with the uniform velocity. It's unidirectional motion with the constant speed. Magnitude of displacement is always equal to distance traveled, and V is equal to U, S is equal to UT. As A is equal, there is no acceleration, A becomes 0. When A becomes 0, S is equal to UT it becomes. A becomes 0, half AT square becomes 0. Simple logic. Okay. So put on these 4 equations, then we'll see the derivations, video we'll see, as well as I'll explain also. Right? Just watch the video.
We will talk about the equations of motion. V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS, and of course, S equals half U plus...
You can write this. Same only I given, different way taken the half outside. Right.
V times T.
Right. The same Sn is equal to formula I wrote. Here also V square minus U square I told. U square comes this side, become minus only. V square minus U square is equal to 2as, or V square is equal to U square plus 2as. Next this. These 4 are called equations of motion.
Show you how to derive all 4 equations, then go over some important points to remember. I've also made a video of worked examples, so take a look at that too. Sometimes these are referred to as the Suvat equations because of the letters used. S is displacement in meters, U is initial velocity in meters per second, V is final velocity also in meters per second, A is acceleration in meters per second, and finally T is time in seconds. Now it's important to remember that the first 4 quantities are all vectors, so for them direction has to be taken into account. I'll say more about this after going through the derivations. Here's the first. We'll start with an equation we already...
You all know the definition of acceleration. Acceleration is equal to A is equal to V minus U by T. From that one, you got the equation number 1.
You know from National 5, A is V minus...
So what is given here? A is equal to V minus U by T. So T take this side. AT is equal to... Just a minute. So AT is equal to V minus U. Correct? T I took this side. So minus U bring this side. So V is equal to U plus AT. Same. So the first equation of motion is simple derivation, which is derived from acceleration only. A is equal to V minus UT, or V is equal to U plus AT. That is first equation of motion.
T over T.
Comfort is an issue, so I only buy Scooty on Rapido. First ride is free.
And rearrange it to give the new equation V is equal to U plus AT. It's a good idea to practice writing down these derivations yourself, so in the first line you'd write A is equal to V minus U over T. Eventually we want to get V to be the subject of the equation, but we can't do that all in one step. We'll start here. So in the second line we have v minus u is equal to at. If we add u to each side, we get v is equal to at plus u. So we can just rearrange the right hand side to give us the equation we're looking for. As I said, try writing out derivations with each step in a new line until you've memorised them. Here's the second one. This one involves a velocity time graph and something else we know from National 5, that displacement can be calculated by finding the area under the graph. We'll use this to derive the equation s equals ut plus half at squared. Imagine an object accelerating uniformly from initial velocity u to final velocity v in time t seconds. The displacement s is found from the area under the graph. So firstly, we have this section, a rectangle. Its area can be found by multiplying its height by its length, giving us ut. The second section is a triangle. Its area is equal to half times the height times the length. The height of the triangle is v minus u, and its length is just t. So its area is half times v minus u times t. If we remember back to the last derivation, at one stage we had v minus u is equal to at. So we can substitute at into the brackets.
Graphical derivation.
If we now multiply out the brackets, we can get the equation we're after.
Half at square.
For the third derivation, we start with the first equation and end with this. V squared equals u squared plus 2as. We start by squaring both sides, which gives us this. We then want to multiply out the brackets. There's more than one way of doing this, but we should end up with v squared equals u squared plus 2uat plus a squared t squared. Obviously, you want to try this yourself. The left-hand side of the equation looks fine, but this part, it needs more work. What we do is take out 2a from this part of the equation, leaving the rest in brackets. Dividing 2uat by 2a gives ut. If we divide a squared t squared by a, we would get at squared. So dividing by 2a would give half at squared.
Barry matchல தினமும் ஒரு புதையலை தேடுங்க. இப்பவே விளையாடுங்க.
So the right hand side of the equation can be written like this. Go over this step again if you're not too sure. Now remember that our second equation was s equals ut plus half at squared. So the term in brackets can be replaced by the letter s, giving us our third equation. The last derivation is the simplest. We start with these two equations. The first says that displacement is equal to average velocity times time, and the second is an equation for average velocity v bar, which is half times u plus v.
Equating 1 and 2.
We then end up with this. S is equal to half u plus v times t. All we have to do is substitute the second equation into this position in the first, like so. To end the video, I'll go over a few final points by answering a question. Remember before that I said that S, U, V and A were all vectors and that only T was a scalar. That's very important when answering questions like this one. So the question says, a girl throws a ball vertically upwards with an
anyway. So this is not
initial velocity.
Right now, we'll see when you are doing the problems, right? When we solve the problems, we can go through this. So that is clearly mentioned what is the importance of the equation, and some important points are given when a body is moving in the uniform acceleration, some conditions. So here the derivations for the equations of motion. First one we are seen here. Already we have seen in the video how to get the equation C. By the definition of acceleration, A is equal to v minus u by t. From that we got v is equal to u plus at. The second one. So we can get from, actually, S is equal to ut. Velocity in time, not displacement is equal to velocity in time. Because velocity is equal to displacement by time. So but there are two velocities are there here. Initial velocity and final velocity. So what do you have to take? Average velocity. Average velocity into time. So what is average of u and v? V plus u by 2 into time. Okay. But in place of v, you can write u plus at. V is equal to u plus at. Substitute here. U plus at plus u by 2 into t. S is equal to. So multiply here. U plus u there. 2u. So 2u plus at by 2 over t. You can write this 2u by 2 plus at by 2. Then cancel out 2 by into t. So 2 into u, ut plus at into t, at square, 1 by 2, at square. That is the formula derivation. Simply from S is equal to average velocity into time. Because there are two velocities are there. One velocity you can directly put it. But as there are two velocities are there, you have to find out the average. That is equation 2. So from combining 1 and 2, you can get the third equation. We have to use the first and second equations to obtain the third equation also. Very simple. See here. V square minus U square by 2as. The simple way you can, by using same average axis, see. First equation and second equation we are using both. By using both, you can get substituting one another. We know average velocity. We know the velocity. S is equal to ut. Substitute there, you can get the v square minus u square is equal to 2as, or v square is equal to u square plus 2as. Right? You have to apply formula a plus b into a minus b. From here, you have to take t. So we know v is equal to u plus at, right? So v minus u by a is equal to t. A come down, na? V goes the u goes here, v minus u. A comes to denominator. So t value you got. You substituting this. S is equal to average velocity into time. In place of time, you substitute this. That is, S is equal to u plus v by 2 into u minus v by a. This is a plus b into a minus b. A square minus b square. Whatever it may be. Into 2 into a, 2a. Yes. You take 2a this side. So v square minus u square is equal to 2as. Simple. So first one is derived from acceleration statement. Next two are by using the first one only. Second one is obtained from the first equation. Third one is obtained from first and second equation. All three are together called equations of motion. And last one is very interesting. It is actually in a particular second how to find out. In a particular second. See, I told you the same given here. In a particular second how to find out the distance. For example, let us see. So this is a very important formula. Suppose you traveled for 5 seconds. Total distance 5 seconds you traveled. 5 seconds you traveled, suppose say 10 meters. He asked what is the distance covered in the 5th second? 5th second. This is total is 5 seconds. 5 seconds travel 10 meters. 5th second means, for example, 1, 2, 3, 4. 1, 2, 3, 4. So 5th second means this is 4 to 5. In between 4 and 5 is called 5th second. 5th, first, second, third, particular second if you ask, we can use this formula. Right? Same from S is equal to ut plus half at square only. In place of t, we wrote nth second. Half, in place of t square, we wrote n square. That's all. So we have to take one. A particular second you want to make n minus 1. Suppose this is nth second. 1 second before means n minus 1. N minus 2. N minus 3, like that we get. So n minus 1 is substituted. That's all. Nothing else we have done. Expanded a minus b whole square formula. This is a minus b whole square formula. A square minus 2ab plus b square. We got this equation. That is useful for finding out the distance traveled by a body in a particular second. In a particular second. Right? Very interesting. So all these 4 equations together are called equations of motion. What do you call? Equations of motion. You can solve. This is completely problematic chapter. You need to solve them. Okay, problems. Okay. So today what we learn is, we learn about the entire chapter. We learn about first motion and time, complete motion and rest we have done. After doing your motion and rest, types of motions. Then we show terminology of motion we completed, like distance, displacement, acceleration, retardation, velocity, speed. Then the relationship between all these things called equations of motion. So there are 4 equations of motion we derived and we have seen through video also. And these equations are the basic mathematics in the physics. Basically, not only a particular chapter, these equations are useful for even in mathematics also, or various chapters of physics. Not only in kinematics or anything. Okay, very, very important. All the four equations. One is V is equal to U plus AT, and second one is S is equal to UT plus 1 by 2 AT square. Third one is V square minus U square is equal to 2AS. And fourth one is Sn is equal to Un plus 1 by 2 n minus 1. Right? These all are the, in all these, what terms are there? Only initial velocity, final velocity, acceleration, displacement, and time. The relation among all these are given there, nothing else. As per the given data, whichever data is given in the problem, based on that, you have to select the which is the formula is suitable for solving the problem. Okay? So that's all for today. So thank you very much, students. In next class, we'll go for the how these equations are influenced by gravitational force. The equations of motions under the influence of gravitational force. So these are generally normal force. But when gravitational force comes into play on the body, how this equation changes? What are the conditions for the equations? That we'll discuss in the next class. Till then, have a wonderful day. Thank you. Thank you all of you. Krishnavati Talent School, Raikal, Gopal Nagar, KTS Alwal, KTS Wani Block, Masterminds Dulapalli,